All right, well, since you guys are struggling with this question, okay, let me give you a hand. It says here that the voltage in the battery is 10 volts, okay? So this is the tough problem, guys, so I make a separate video for this one. It says here the voltage is 10 volts, okay? And then the values of the resistors are given here. So R1 is 900 volts, or 900 ohms, R2 is 200. They just go up by 100. So R3 is 300, 400, 500, 600. It's easy to remember, okay? Now, when you're solving this, the first step is to find the total resistance, right? Okay, so let's look at this picture. What you have to first identify the parallel part of the circuit. Okay, so what you do when you're doing that is pretend you're a little electron going for a ride. Okay, so we follow this little blue path here. We take through our resistor, and then right here, and this is important, I'm going to put it red alert, okay? That is a branch point, that's a junction. So that is the beginning of the parallel section of the circuit. Now at this point we have two options. You can take this path, okay, and go that way. Or you can take, and I'll use a red color, you can take this path and go this way, okay? Now here is where they meet back up together. So the green and the red branches are parallel parts of the circuit, okay? Now, when they join back together, they're back to being blue. Everybody's back together, one big happy family going back up to our battery like that, okay? So right here we have our circuit. Now, here I'm going to identify this part as the red branch. Okay, so that's the red branch there. That is one path on the parallel circuit. And here, the green branch is the other path. Okay, now that we've done that, okay, so if you like, in the blue path, I'll just say this before I say anything else. This blue path here, for the blue path, everybody goes through those. Okay, so the two blue resistors are in series with each other, okay, believe it or not. And this whole green section here that I'll just block off in green, that is the parallel part between the two junction points. Okay, now actually I'm going to erase some of that because you can't see my green word there. Okay, so now that we've done step one, we've identified the parallel part. Now okay, so like that's not something we can write down, we highlighted it. Okay, so we've got the parallel part of the circuit. And what we do next is we look on, like the next question is to look on the two branches. So the green one has only one resistor. Here, I'll use the highlighter, R5. The red one, though, has three resistors, R2, R3, and R4, okay? So the red one has three resistors. The green path, though, only has one. Okay, one resistor there. So for the red one, the first thing we need to do is add up the resistors that are in series. So for the red path, I'll put it in red writing. The red path, okay, the total resistance on the path is going to be 200, that's R2, plus 300, plus 400, okay? Now, 200 plus 300 plus 400 is 900 ohms. And that's what I meant when I said 900 ohms. I didn't mean it was the total for the entire circuit. I had erased a lot of it. So anyway, the red path, just the red path, has 900 ohms. The green path has a resistance of just 500 ohms, just one resistor there. And that's the parallel part. These two things are in parallel with each other. Okay? So therefore, the total resistance, 1 over RT, of the parallel circuit is not of the entire circuit, just the parallel part of the circuit will be 1 over 900 plus 1 over 500. Okay? Now, I'll do it for you, okay, just so you see how it works. Let me get my calculator. 900, these are going to be plus 500. I get 321.43. So 321.43 ohms. Now that's the total resistance of the parallel part. And I don't like highlighting it too much. Actually, you know what? I'll highlight it in a better color. I'll go back to using the yellow highlighter. And this blob of yellow, the resistance of that blob is 321.43 ohms. Okay? Now, the blue path, everything's in series on the blue path. And the yellow blob is like, think of it as just some device that's in series with the R1 and R6. And so for the whole circuit, I'll do it in blue, the whole circuit, the total resistance therefore will be R1, which is 100, plus 321.43, which is our yellow highlighted section there, plus R6, which is 600 ohms. So it's going to be 100 plus 321.43 plus 600. Okay? So what does that add up to? 9, here, I'll just put it in the calculator. Plus 600 plus 100. That's 1021.43. 1021.43 ohms. And that's how you find the total resistance of that circuit, okay? Now, the next step, now that we've done, like, you know, basically step 3, we found the total resistance. So number 1, we identify the parallel part. Number 2, we find the resistance of that parallel part, okay, like including like if there's any ones in series on the branches, okay? And then what we do is after that, we figure out the resistance for the entire circuit by adding the elements that are up in series. So now I'm going to find the total current. Now to get the total current, you're going to go like this. Let me switch back to black here. I'll do it down here. The total current will equal the voltage in the battery divided by the total resistance. Well, the voltage in the battery is a paltry 10 volts. Okay. Yeah. You're not going to get a lot of current here, to be honest with you. I feel like it's almost a typo that they have such a small current, but we'll just go with it. Okay, times 10. I get 0.00979 amps. So that's a very tiny current, but whatever, we don't really care what the number is, right? It doesn't have to be this beautiful whole number or anything like that. What's wrong with decimals, I ask you, okay? So anyway, now we know how much current is coming out of the battery. So we come up here, we play our little game. This is like, if you like, step 3 or whatever, step 4, where step 4, I guess, where we're finding all the missing values. So now what we do is we have to play our little game where we follow the current around. So, oh, I don't know what's going on here. It's being stupid with me. Okay, just a moment. Okay, that's better. All right, so now we'll play our little game where we say, okay, I coming out of the current here, IB, if you like, equals 0.009979 amps. Now we follow that across the blue path, and we see that going back into the battery must also be 0.00979 amps. And so what we realize is R1 and R6, those two currents, I1 has to equal 0.00979. And I6 also has to be 0.00979. Okay? So we've got those two things. Now we can find the voltages. So now we proceed as usual, right? Once we find some currents, we find the voltages right away. So V1 will equal I1 times R1 according to Ohm's law. R1 is 100, so I just have to multiply that by 100, and I get 0.979 volts. R6 though is 600, so I'm going to times that by 600, and I get 5.874 volts. So this is R6. So this is 5.874, pardon me, I keep getting spam calls on my phone. Equals I6 times R6, which is equal to 5.784. Okay, now the trick now is we subtract from 10. Okay, we know this guy is 10 volts. It was given in the question. So we're going to subtract from 10 to find out what V5 is. So V5, if you take the green path, you're only going through one more resistor, right? So V5 will equal 10. Okay, you know what? There's not enough room for me to write it there. So let me write it here, down here. V5 will equal 10 minus 0.979 minus 5.784. Okay, so now I'm just going to do that. Negative minus 0.979 plus 10. And I get 3.15. It's almost equal to pi, really. 3.15, whoops, not amps. I'm sorry, volts. Okay, now that is the voltage across R5. Well, that means we can find I5. I5 is V5 over R5, right? So what I do is I take that voltage and I divide it by 500, and I'm going to get these really tiny currents. I get 0.006294 amps. Now, here is the weird trick you have to play. We come up here to this junction point, and we realize that we have there 0.00979 amps going into the junction this way, and then going that way we have 0.006294 amps. So this one is 0.006294 amps. Now the difference is going to go that way, okay, along the red path. So the red path is our trickiest path here. So now let's do it. I'm just going to subtract. Okay, so we've got this one plus 0.00979, and I get 0.003496. So this current here, I equals 0.003496 amps. Okay, now that current is the red current up through all three of those guys. So this is I2, it's I3, and it's I4. Okay, all three of those currents have to be the same along the red path because it's just one path there. Okay, along that red path. So now that we found that current, we can find the missing voltages by just taking that current and multiplying it by the resistors. So first I'll times it by 200. So this one here, V2, will equal 0.699 volts. Okay, V3 times it by 300, I get 1.04 9. And then finally V4, I go that current times 400 and I get 1.399. 1.399 volts. Okay. So, like, long story short, okay, filling in the chart here, we get R1 has a voltage of 0.979 volts. R2 has a voltage of 0.699 volts. R3 has a voltage of 1.049 volts. R4 has a voltage of 1.399 volts. And R6 has a voltage of 5.784 volts. The current is R1 and R6 both have 0.00979 volts. Okay, and 0.00979 volt, or sorry, amps, pardon me. It must be the afternoon. Amps and amps like that. Okay, and finally the red path there has a current of 0.003496. So all of these 0.003496, 0.003496. R5 is different though. Oh, they skipped one. They skipped R4. There's no R4 in the table. Okay, well, whatever. So R5 is the different one. It's 0.006294 amps. Okay, and we skipped R4 for some reason. I don't know why, but anyway, there you go. All right, so that's it. Piece of cake, right? Anyway, as I was explaining it, it took a long time. I'm never going to give you one that hard, but on an assignment, it's good to get your head around hard ones, and that way the ones on the test will seem easy by comparison. So if you can do the other questions that are on this sheet, plus the ones in the textbook, I'm happy with that. This one is meant to be challenging, and the voltages are small and annoying, and you get really small numbers for the currents and some of the voltages, but that's it. All right, you're welcome. Bye-bye.